I am Anil Kumar. Welcome to my series on trigonometry. Now we will learn how to find the angle when we are given reciprocal trigonometric ratio. I mean the secondary trigonometric ratios like cosecant theta, secant theta and cotangent theta. So the question here is, calculate the angles theta where theta is between 0 degrees and 360 degrees for the following trigonometric ratios. Cosecant theta is minus 2, secant theta is 2 over square root 3, cotangent is minus square root 3. Cosecant theta equals to 1, cotangent theta is 2.5, secant theta equals to minus 3.2456. Now the last two we will be doing using calculators. The first four can be done using special triangles. So no calculator required for the first four, but we'll need calculator for the last two examples. Okay. So what do you need to know? First, very basic, sine is the ratio of opposite to hypotenuse. Cosine is adjacent to hypotenuse. And tangent is ratio of opposite to adjacent. Right? Then you should know these reciprocal ratios are related with primary trigonometric ratios in what fashion? For example, cosecant theta is reciprocal of sine theta. So if cosecant theta is minus 2, that really means that sine theta is equal to minus 1 over 2. Now negative, even if you write in the denominator, it basically means negative, right? Secant theta is reciprocal of cos theta, so we could write this as cos theta is equal to, you can make the reciprocal on this side, right? Square root 3 over 2. Cotangent is the reciprocal of tan theta, so that is tan theta equals to minus 1 over square root 3. And here, cosecant theta is the reciprocal of sine theta, so we'll write this as sine theta is equal to 1. 1 is reciprocal of 1. Cotangent theta is reciprocal of tan theta, so we're going to write this as tan theta equals to 1 over 2.5. And here for secant we'll write cos theta equals to 1 over negative side 3.2456. Why are we writing in terms of sine, cosine and tangent? Simply because in our calculator we have sine, cosine and tangent, and we cannot use calculator for cosecant, secant and cotangent. Perfect. So that is the first step which you need to do. Second step, we have to see that all the angles which we are looking for are between 0 to 360 degrees. So we need to look into our quadrants. When I say sine theta is negative, it means what? Well, you should know the cost rule, right? So let me write down here. All are positive in quadrant 1, sine in quadrant 2, tan in 3, and cosine in quadrant 4. Now, what do you need? You need sine theta to be equal to minus half. It is going to be negative in quadrant 3 and in quadrant 4. Perfect. Now, does this half remind you of a special triangle? It does. So if you remember those special triangles, we will be using them here to solve these questions. Now I normally make 30, 60, 90 triangle in one common triangle. So we know this is 60 degrees. In that case, that will be 30 degrees. This is going to be 90 degrees and the sides are 1, 2, right? This is square root of 3. Now, this is one thing. Second is you can also use unit circles. I prefer using the triangles. They are very handy and very versatile, right? Unit circles I think is hyped. Now, when we say that sine theta is half, we have to actually look for the acute angle all the time, right? So we'll say, how about the sine alpha? When I say alpha, it means we are looking for solution in quadrant 1. And then we'll find its equivalent value in these two quadrants. So for half, I get the value opposite over hypotenuse with 30 degrees. So from here, I do get alpha equals to 30 degrees, right? So for an angle of 30 degrees, we do get half. But what do we need? We need negative half. Okay, so where is negative half? Negative half is the value of sine when the angle is in quadrant 3 or 4. However, the acute angle will be 30 only, right? So this is 30 degrees. We have to always report the principal angle. So I hope you understand what I'm saying. We have to give this as our answer. What is this angle and what is that angle? You get the idea, right? So these are the two angles. So we'll say, well, one angle is theta equals to 180 degrees plus 30 degrees. That is the first one, right? And the other one is full circle less 30, which is 360 degrees minus 30 degrees, correct? Now that is 210 degrees and this one is 300 degrees. So these are the two solutions within the given interval 0 to 360 for the first example. So I hope that is absolutely clear. So it's kind of important to understand this concept, right? Once you understand, it is very simple. Now see how it goes. We have to now work for cos theta. So we specially make our quadrant and say, well, we are looking for a positive value. We know the rule. Cos is positive in these two quadrants, correct? So we are looking for a solution in these two quadrants. 2 over square root 3 reminds us was, well, cos theta of square root 3 over 2, which is adjacent over hypotenuse. Square root 3 is adjacent to 30 degrees again, right? So here we get acute angle alpha as 30 degrees. You see that? But we need theta. So what is theta equals to? Well, it is 30 degrees here and 30 degrees there. Means one of them is correct in quadrant 4 since it is positive. The other one is 360 minus 30, right? So which is 330 degrees. You get it, right? You could also write plus minus 30 degrees, but we need to write within the interval 0 to 360 minus. So you have to report the angle, which is this one, which is 30, and that one, which is actually 360 degrees minus 30 degrees. So we wrote 330 degrees. Is that clear to you, right? You see, it becomes how efficient, right? Let's take up the next one. By this time, you'll be an expert. Cotangent theta is the negative value of square root 3. Tan will be negative reciprocal. That means 1 over square root 3. Now, we are looking for a negative value. When is tan theta negative? Well, tan theta is negative in quadrants 2 and 4, right? So remember the cost rule, right? So all silver teacup. Cost rule, you can say anyway. Okay, so now we know we are looking for 1 over square root 3. We'll look for the acute angle first. That is to say, what is tan alpha equals to 1 over square root 3? Acute angle means we try to find this angle where all are positive. Perfect. Now 1 over square root 3 tan is opposite over adjacent. Opposite over adjacent is 30 degrees, right? So that gives alpha as 30 degrees. Okay. Now what? Which are our answers? Our answer is the acute angle of 30 degrees within quadrant 2 and in quadrant 4. So the two answers should be what? Theta should be equals to 180 degrees minus 30 degrees. That is one. This other one is theta equals to 360 degrees minus 30 degrees. So we again get the answers as 150 degrees and 300 degrees. Does make sense to you? So I hope you are getting the point, right? So that is how we do it. Now purposely I just took values which work with one triangle, right? You know the other triangle, which is 45 degrees one. You could use any. These are the two special triangles. Now, let's move forward in a fresh page, get the solution for the next 3 questions. Now, let's take up the last 3 parts of this question. We need to calculate the angle theta, where theta is between 0 to 360 degrees. For cosecant theta equals to 1, let's begin with this. Now, in this case, cosecant theta is 1, it is positive. So where could we get the solution? Well, cosecant is reciprocal of sine, so that basically means that sine theta is also equal to 1. Now sine theta is 1 for just one angle, which is theta equals to 90 degrees, so that becomes your solution. Now when it comes to 1 and zeros, I prefer to sketch the sine graph, right? So that helps. So a sine graph normally gives you fast values for values like 1, -1 and zeros. Do you see that part? So whenever it is positive or negative 1 or the zeros, look at the graph rather than the triangle. We don't really have a triangle for 90 degrees and 0 degrees, correct? Okay. The next question here is cotangent theta equals to 2.5. So that means that tan theta should be equal to 1 over 2.5. Now this value is positive. That means we are looking for solutions in quadrant 1 and 3, right? So because it is positive, these are the two. Now we are going to use the calculator and find the answer for the positive angle alpha, right? So that is always the case, which will be a part of our solution. So we will say alpha equals to tan inverse of 1 over 2.5, right? So let's do it. So in my calculator, I've already put the mode in degrees, which is number 3. You have to check the setting also. Sometimes it could be in radians. Okay. So we do shift tan inverse 1 divided by 2.5 bracket close equal to. So we get an angle which is 21.8 degrees. So that is only one solution. A calculator can only give you one solution, right? So we know for tan the angles are 180 degrees apart. So these are the two angles, correct? So we got one theta value as 21.8 degrees. The other one is 21.8 degrees plus 180 degrees, correct? So let's add 180 degrees to this and write down our answer. So which is equal to 201.8 degrees, correct? So these are the two solutions within the given domain for us. Is that clear? The last one here is about the secant theta, and we are looking for negative value. Negative value will be in quadrant 2 and 3 for cos, correct? So those are of our interest. So reciprocal ratio will be cos theta equals to -1 over 3.2456. I just took a number at random. But whenever we are working with this, we normally find the acute angle alpha, right? So I'm emphasizing on this. So we say, well, cos alpha is a positive value, right? 3.2456. Let's find the value of alpha, which is cos inverse of this. Again, shift cos inverse 1 divided by 3.2456 bracket close equal to. Now that gives us an angle of 72.05. Okay, so one of the angles, this is the acute angle. We are really interested in the negative value, right? So that means the two solutions for us should be what? One in quadrant 2, the other one in quadrant 3, where the angle alpha is 72.05. So angle theta is how much? Angle theta will be 180 minus and 180 plus. So the two angles will be 180 degrees plus 72.05. You can write 1, let me write like this, or 180 degrees minus 72.05. Correct? So let's take away from 180 72.05. Now sometimes they'll mention what accuracy they need, right? So one of the angles is 107.95. The other angle is, now we'll just change this to plus sign, right? Okay. So we'll change this to plus, and it has to be more than 180. So that will be 252.05. Correct? So these are the two solutions. Now, if you want to round them, it depends on your question. Based on that, round them, right? Normally, if not mentioned, one decimal place is good enough. Anyway, What you have learned in this particular video is that whenever you are given the secondary ratios, which are reciprocal of primary ratios like sine, cosine and tan, first write them in terms of primary trigonometric ratios, sine, tan and cos, right? Then to find the angle, we have to see the sine first. So apply the cast rule, right? So apply the cast rule, check in which quadrant we are going to get the solution, right? So once you know, normally we get two solutions within a domain of 0 to 360. There are, however, few exceptions. For example, you saw sine value is 1 for only one value and negative 1 also for one value. It is 0 for three values, correct? So these are few exceptions. Otherwise, normally you expect two answers within the domain of 0 to 360 degrees. Step number 1 is to find the related acute angles. So first step, find related acute angle. That is the first step. Once you find that, then based on the sign, write your answer. And then the angle theta. When we say angle theta, it is the principal angle. You have to go counterclockwise to get this answer, right? I hope that is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thanks for watching and all the best.